Welcome to the 7th lecture in module 4. Where we are going to discuss about the structural health monitoring design applied to tension leg platforms in lab scale, lecture 2. This is a continuation of the previous lecture number 6. So, let us continue to discuss what we had left in the last lecture. We were talking about the wireless sensor networking design. As I said in the last lecture, the primary component of wireless sensor networking is the sensor node. The processor unit is connected to the external devices using general purpose input output pins with the external devices which are connected through the GPIO pins. There are two options: integrated circuits which is I2C can be used, or one can also use serial peripheral interface which is SPI. Any one of these protocols are generally used for such wireless communication. In the present study, we have used I2C communication channel, or I should say communication protocol. There are many advantages of using this. I am looking at the importance one. One is it has got a sufficient memory. It has sufficient to program. Third, from sensor units. So, this device is recommended to be used with an extended scalable memory card which is connected to elevate or let us say enhance the data storage capacity. This is required to store the data temporarily until for post processing. The PI board is powered with an external battery which has extended period of time to conduct the experiment. Sensors used have low power consumption, so that they can be even operated from mobile stations. Because that is required, as offshore platforms are mostly inaccessible. One can also use alternative methods of power. We also mentioned this in the previous lecture. For the completion sake, let us look into the details of alternative methods of power. One can use energy harvesting techniques, like use of solar power, wind power, even wave energy for powering this SHM system. One can also alternatively use ultra power circuit boards which operate on nanowatts for powering networking components. The details can be seen more at Waheed et al. 2016, Lee et al. 2016. The sensing unit used in the present study is MPU 6050, which is a combination of triaxial gyroscope, accelerometer, motion processor. So, MPU 6050 used in the present study is a combination of these. It can measure both acceleration and rotation, about all the 3 axes, is a triaxial component, a 16-bit analog digital converter to collect and process the output from the sensors. It can measure plus minus 16 G, whereas the full scale range is plus minus 2 G. The sensitivity is 16384 LSB per G. Is connected to the PI board which acts as a transceiver unit. Now, most importantly, in the wireless sensor networking, sensor nodes act as independent module. They measure and also send data directly to the server. Through transmitter. Sensor nodes are implemented on 4-step basis. Acquire, transmit, store and report. The another important feature we have in this case is self diagnosis, or I should say self organization of the sensors. The advantages of this case could be no need to use large number of sensors, because the intermediate nodes will participate in forwarding the data packets between the source and destination. Let us look at the sensor architecture. This is the wireless sensor networking architecture, which is currently being designed and used for the TLP in experimental lab scale. There is a base station which has got a web application server. The sensors are connected to the base station using GPIO pins, as we discussed. They communicate through intranet and received and processed either through LAN or wide LAN systems in the architecture given to store and process the data as we get. Has the following features. A component level integration of multiple software and hardware units, which is a very important feature of the design. The model what you see here is a tension leg platform having a square deck which is painted in green in color. All the four corners which I am marking here are the locations of buoyant legs, which are further connected to the tethers, which are marked as position 1, 2, 3 and 4 in a clockwise rotation or angle. You can see here the deck houses both wired and wireless sensors. You can see here the wired sensors and wireless sensors are placed on the deck, which has got capacity to measure acceleration, inclination, that what we call as rotation, and of course, the axial force in the tethers. The model is installed in the deep water wave flume as the tethers are subjected to axial tension. Is about, let us say, in the deep water pit, which is about 4.5 meters. From one end the wave is generated and other end the wave is absorbed at the beach end. Okay, it is about approximately 85-90 meters long. That is the test bed which we discussed earlier as well, is installed on the deck of TLP on the lab scale. Now, IEEE 802.11 protocol is used to transmit the data through the transmitter in case of wireless sensor networking. All sensors and base station are connected to the same network. The server at the base station receives the data, stores the data in local MySQL database.